right? So bias and variance. So one way I like to think about it, and I think you might find it easier if you think about it as well, is that bias is underfitting, variance is overfitting. Simply, So for example, you know, let me go to my notepad. Okay. So for example, if you have this data, right? This is your y parameter, this is your x parameter. Okay. So from looking by visual inspection, you can see that a quadratic curve will fit this, very well, like this yellow curve, right? But let's say you are fitting a straight line, a linear curve, a plus bx. In that case, you are underfitting, right? On the other hand, if you are using, let's say some higher degree polynomial, right? Okay, let's say fourth order polynomial. Yeah. A plus b x plus c x square plus d x cube plus e x to the 4. Okay. So a fourth order polynomial you are fitting. So what you're doing is that you're overfitting the data. So this data might do well on your training set, but this will definitely fail on your test set when you're testing the data ultimately. Whereas in this curve, it is already underfitting. It is also bound to fail in your test data. So both of this will have high errors, but this is the case which we call bias, and this is the case which we call variance. As I said, easy way to remember: bias is underfitting, variance is overfitting, right? So if you see, this is your training set. So variance, if you see, will have almost negligible error in your training set, right? But in the validation set or in the test set, it will have higher error because it is overfitting the data. But your test set might not represent the training set, right? Test set might be little bit different. Although your algorithm is perfectly fitting the training set, it will not fit the test set. So that is where variance comes from. So one feature of variance is that low training error but high test error. On the other hand, bias has both high training and test error. Okay. So that is the mainly the difference. Again, now I'll come back to my slide. Okay. So if you see, so this case, you have both. So I think the red line is the in this graph. The red line is the uh, test error, whereas the dotted line is the training error. Whereas the yeah. So in this case, both are high. The test and the training both are high. So you get bias because your model is being overfitted. Whereas in this case, variance, your uh, your test error is high, but training error is a little bit low. Right? It starts from low, but as you increase the model complexity, it will get higher. Right? Okay. So yeah. So the best way to go is find an optimal region where you get both cross validation error low and your training error as low as well. Right? So here is again one more graph. If you see, so this is the case of high variance, whereas overfitting, the right top graph. So you see that this is the error we are calculating. As I said, the training error will be high, but as you increase the training set size, the training error will become higher because you're like overfitting the model, right? You're overfitting the model, but at the end, if you increase more and more, training examples. So let's say this is a one-dimensional data. If you add more features and add more training set, your error is going to go high because you're already overfitting and you'll not be able to fit the extra data points that you are getting, right? So that's why training error will rise. And again, this is the test error in green, which will decrease. And you see this gap, right? So this is the gap that we'll observe in variance. Compared to bias, when you are underfitting data, you will not observe this gap. So error will again both increase, but you will not observe this gap. So right now, so the main question we should ask is that how to reduce variance and bias both, right? So variance, if you see, we can reduce by increasing the training set size. So if you extrapolate these two lines, you know, your test error and training error will go towards the desired performance, and your both errors will diminish. And sorry, the test error will diminish, and you will go towards the desired performance by increasing the training set size. How to reduce bias? You see this both the training error and test error are high compared to the desired performance, as I showed you from my notes, right? So how to reduce bias? There could be many ways. One of the ways is increase the number of features. So as you saw that our model was underfitting in case of when we use a linear model, right? So if you see in this graph, we're using a linear model, right? So this one. So this is a linear model. So what we do, we can increase and add more complexity. Let's say we can increase cx square, and in that case, we'll fit the graph uh, correctly, right? So that these are the two ways which you can reduce, bias and variance.